Hi, programming and data structures. Topic for today is associativity and precedence. You got 1 minute to solve. Time's up. Let's see the answer. Okay, so in this question, you might have noticed a few new operators. As we saw in one of our videos, the associativity and the precedence table, right? What we saw. So the bracket will be having always the highest precedence. This plus plus, right? If you check in the table, we can see that it is coming next. Star will be after it, and then the shift operator will be coming next to it. So let's look at the question. So now int x equal to 1 into 2 by 3 plus not 4 star 5 by 6 into 7. So bracket will always be higher precedence. So this gets evaluated first, then this. Now within the bracket, let's check. Both have same precedence, multiplication and division. So how do we evaluate? Based on the associativity. Associativity tells us we need to evaluate from left to right. So first 1 into 2, then 2 by 3. Since both are int, we get 0. Now next bracket we will solve. Now in the second bracket, you see this not operator. Do you remember what was the precedence? Is it greater or less than multiplication? Just have a look at the table. Okay, so if you check the table, you will see that the not operator is having higher precedence than multiplication. So this will get evaluated, then this. These both. So now there's a conflict. We see three operators. All same precedence. How do we evaluate? Based on associativity, which is left to right. Okay, let's solve it. Not 4. Okay, not operator, what does it do? So think of not as like negation. Basically, we're saying if something is true, take it as false. If something is false, take it as true. It's like some sort of reversal. You can say it like that. So since 4 is true, right? So not 4 will be giving you 0. 0 times 5 by 6 into 7. Now, since associated left to right, how do we do it? So 0 times 5 will be coming. So 5 into 0, 0 by 6 into 7. 0 by 6, which is 0, 0 into 7, which is 0. So we are getting the x value as 0. Just remember, bracket, then we have not plus plus, then we have star, then we have shift. Okay, now next. So you must be seeing there is this highlight, right? This or and at. Now when you evaluate it, did you get ZS 10, ZS 11? Maybe not. So you must be wondering how this two lines are different. So we'll be learning about one more new concept today, that is about the short circuit evaluation. So once we have an expression, right, it could be a very huge expression. A greater than B plus C minus D times E. So many operands and operators. So now there is one way the compiler doesn't need to evaluate everything. So we have some long expression and we have an OR operator and we have expression 2. So think expression 2 is very huge. Now, if you think about the OR operator, right, you know the truth table, right? True, false. So OR is always true in these three cases. Either one has to be true or both are true, it gives true. Only when both are false, it is giving you false. So since we know this, now the computer is thinking, suppose expression 1 is true, right? We already know that if one of them is true, anyway the answer is going to be true only. So do we really need to evaluate expression 2 again? No, we don't need to. So short circuit evaluation, because of it, now the compiler, right? We know that if one of them is already true, we don't need to do the other one. So expression 2 doesn't get evaluated. So let's look at that expression. So in the expression we're seeing, right, we see this OR operator. So if this becomes true, then we don't need to evaluate this. So let's check. Okay, how did you evaluate this? First comes the bracket, second comes the plus plus, and third comes the and. So let's go inside the bracket, plus plus y. Y is 8 plus y plus 8 and 9 plus, which evaluates to 9 and 9. So we're getting the value as true. So this true, right? So since it's already true, it is not going to do the rest of the expression. That is why we're seeing the value of z as 10 from the 9 plus. Remember, this plus and this plus is different. One is pre-fix and one is post. Pre means you'll do the plus first and then you store the value. Post means that we take the value and then only we do the plus. So suppose you're storing z. Suppose we take some, okay, so suppose we take some variable a is equal to plus 8 and a is equal to 8 plus. So here, since we're doing plus first, we'll get a as 9. But here, since we're taking the value first, it becomes 8. So that is why we're getting the answer as 10. Okay, now suppose we replace this OR with AND. In the truth table of AND, we see a different story, right? Only if both are true, it evaluates to true. In all other cases, it's false. So now the compiler, right, it sees AND. So both sides, this expression 1 and expression 2, it needs to evaluate. So let's have a look at the expression. So plus 8 and 9 plus and 10 plus star 1 shift. So this gives you 1. Now from here, it became 10. That is why we're doing 10 plus plus. So 10 into 1 shift 4. That is 10 shift 4. So this, right, there are two types of shift operators. One is the left shift and one is the right shift. This is left shift, this is right shift. So what is the shift operator doing? Suppose you have some value like 1, 0, 0. Now when it is right shift, we're shifting the bits. It is operating bitwise, okay? So on each, this is, remember, this is not the decimal value 100, this is binary 100, which is 4, binary of 4. So when we're doing bitwise, right, it will shift. So we say shift 1 time, we get 1 0. Shift 2 times, we get 1. Now here in the question it is 10 right shift 4. That is shift 10, the binary value, by 4 times. What is the binary value of 10? 1 0 1 0. Now shift this 4 times. 1 0 1 1 0 1. And we have, next time when we shift, what happens? It becomes 0. We shifted by 1 bit, becomes 101. Shifted by next bit, it becomes 10. Shifted by another bit, becomes 1. Then finally, when you shift right, any bit is there, it becomes 0. So finally, when you evaluated this expression, right, we got 1 and 0. That is why we're getting y as 0 in this case. And note, it was 10 plus plus. That's why it is coming as 11 here. Okay, let's just do an overview of whatever we learned. So today we looked at some more operators today. One is the plus plus and one is the shift operator and also the negation operator. Plus plus comes in two forms. Plus plus can be either pre or post. Pre means that you do your increment or your decrement and then you assign the value. Post means that you first assign the value and then only you do an increment. Like we saw in the example, when we do a is equal to 8 plus plus, we're doing the assignment first. So a becomes 8. Then only we'll increment. So next time, right, when you print, when you're actually doing, so next time, suppose this a, right, suppose it was a variable, a was stored, 8 was stored in this variable x. Next time when you look the value of x, right, it won't be 8, it will be 9. But the value of 8, a became 8. Next operator we saw was shift. Shift is of two kinds. We have the left shift and the right shift. Left shift will shift each bit towards the right, left, and right shift will shift towards the right. As we saw in our example. So we had 4. When you do left shift, right, when you shift by 1 bit, it becomes 100. But when you're doing the right shift, it became 2. Next operator we saw was not. You can think of it like some sort of reversal. It does the negation. Negation of true becomes false. Negation of false became true. Something else we learned new today. What was it? Short circuit evaluation. So when we have a long list, like the expression is having many operands, many operators. Think of some huge expression. So whenever the compiler sees OR, right, as we saw in the truth table, if the first expression is true, then we won't evaluate the second expression. But in case of AND, right, if this is true, as we saw in the truth table, only when both are true, then only we can say the final result. So in this case, we need to evaluate both expressions. But in the case of OR, we didn't need to do that. That is why the result is coming as different in case 1 and 2. Here, this part didn't get evaluated. Here, this part got evaluated because of the difference in the operators. Thank you.